All right, new problem. We want to find the antiderivatives of 6x plus 7 over x plus 2 squared. Okay, so we have a rational function here, polynomial divided by polynomial. So we should be able to do a partial fraction decomposition. So we want to take this fraction there, 6x plus 7 over x plus 2 squared, and we're going to try to break it up. So I want to point out the bottom has already been factored for you. X plus 2 squared, that's factored already. So if the bottom wasn't factored, we'd have to do that. All right. Now this time, so you're supposed to make a wild guess as to how this can be split up. We have what's called a repeated factor here. If you've got x plus 2 squared, that means you have x plus 2 times x plus 2. So x plus 2 is a factor that's repeated twice. When this happens, when you have a repeated factor, your guess needs to change. So you're going to guess that this is going to look like a over x plus 2 plus b over x plus 2 squared. So on a different problem, if you had something like 1 over x plus 2 to the fourth, you would guess that that looks like a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed plus d over x plus 2 to the fourth. So that's what your guess would need to look like if you had a factor repeated 4 times. All right, so we want to solve for a and b here. All right, so I'm going to multiply both sides by x plus 2 squared. Multiply the left side. All right, multiply the right side. Got to distribute. All right, so now I can do some canceling. X plus 2 squared divided by x plus 2 squared. All right, those guys are gone. X plus 2 squared divided by x plus 2. One of them crosses off. Just left with x plus 2 times a. Over here, x plus 2 squared crosses off with that x plus 2 squared. All right, and I'm left with this. So now remember, we have a bunch of different ways to solve this. So one way is to use that method 1 where I multiply stuff out and compare numbers. So we can do that. All right, let's try that first. So I can say 6x plus 7 equals ax plus 2a plus b. All right, now if I do that, I see, aha, I got a line on the left side, I got a line on the right side. I'm going to group these guys together. So I say, oh, the slopes of these lines, they got to be the same because these lines are equal. So a must be 6. Then you say, okay, the y-intercepts, they have to be equal. So 7 must equal 2a plus b. But wait a minute, we already know a. So 7 equals 2 times 6 plus b. So b must equal -5. Subtract 12 from both sides. Aha! So we figured out our a is 6, and we figured out our b is -5. So we say, great, we can split up this fraction now. All we've done so far is algebra, by the way. We haven't done any calculus. So all we've done is we figured out, oh, we can take this fraction, and we can split it up and make it look like 6 over x plus 2 plus -5 all over x plus 2 squared. So, all right, finding antiderivatives this time, okay? Well, think of this as 6 times 1 over x plus 2. Now with this guy, think of this as minus 5 times x plus 2 to the negative 2 power. All right. So to find antiderivative here, an antiderivative of 1 over x plus 2, well, we can do 6 times natural log absolute value of x plus 2. Now here, we got to undo the power rule. So if you had to find an antiderivative of, say, just plain old negative 5 times x to the negative 2, well, what you do is you'd say, okay, I must have started a power higher. So you must start with negative 1. And so you can say, okay, if I take the derivative of x to the negative 1, I get negative 1 x to the negative 2. Okay, well, if I put a 5 here, the derivative of this guy is this guy. Well, finding an antiderivative of this guy is very similar to finding an antiderivative of this guy. So I'm just going to take a wild guess here, and I'm going to guess that an antiderivative of 5 times x plus 2 to the negative 2, I'm going to guess that it's 5 times x plus 1, or 5 times x plus 2 to the negative 1. And we can check if we're right. I mean, if you bring down the negative 1, you get negative 5. Subtract 1 from the power, get negative 2 power. Use the chain rule, multiply by the derivative of the inside, which is 1. Yay, it worked.